This is a problem on dynamic rotor balancing. A rotating shaft carries three unbalanced masses 4 kg, 3 kg and 2.5 kg. So at radial distances, now 75 mm, 85 mm and 50 mm, and at the angular positions of 45 degree, 35 degree and 240 degree respectively. The second and the third masses are in the planes at 200 mm and 375 mm from the third masses. 200 mm and 375 mm from the plane of the first mass. The angular positions are measured counterclockwise from the reference line along x-axis and viewing the shaft from first mass end. The shaft length is 800 mm between bearings, and the distance between the plane of the first mass and the bearing at that end is 225 mm. Determine the amount of the counter masses in planes at 75 mm from the bearings for the complete balance of the shaft. The first counter mass is to be in a plane between the first mass and the bearing, and the second mass in a plane between the third mass and the bearing at that end. This is the figure that you can note down. Just draw the figure. You will understand easily. This is one bearing and this is another bearing. The length from here to here is 800, and this is the reference plane. RP means reference plane. This is another plane for which the mass MC2 is there, and here the mass MC1 is there. Here it is the mass is there. M1, M2, M3, 1, 2, 3. There are 3 planes and these 2 planes. So there are 5 planes. This plane is reference plane. So all the distance should be measured from this plane to the M1, M2, M3, MC1, MC2. Now you understand here the solution is just to see L1, L2, L3, LC2, क्योंकि LC1 is 0, M1 R1, M1 R1 L1, this M2 R2, M2 R2 L2, this M3 R3, M3 R3 L3, this. Then RC2, let us assume it is 40 mm. It is not given. Theta 1 is 45 degree, theta 2 is 135 degree, and theta 3 is 240 degree. Okay, so just I am not going to utter all this, just observe and write. This is the cost component. Here you will find that there is no MC1 because LC1 will be 0. So that is 0. This is the Y component. Equal to 0. This is the equation coming from here. This one is that 4. This is 1 equation, 2 equation, 3 equation. So this is the 4 equation. This is okay. These 2 equation from this above 4, 5. So from here squaring and adding you will get MC2, RC2 and LC2. This is the value of that. So MC2, RC2 and LC2 is given. So MC2, RC2 is this. Now RC2 we have assumed 40. So MC2 can be found out. This much kg. This is the answer of MC2. Okay. Now theta C2. This one. So theta C2 is this. This is this. Okay, and this will be the position of MC2 and this will be theta C2. So then go for this the force balance equation, because here contains MC1. Knowing MC2 and RC2 you can find out this one the same way as done for the static balancing. Is equal to 0, or this is 45, so this is sine, this is cos, this is sine, not or, it is second equation. Okay. Okay. So this is okay. This is also okay. So MC1, RC1 will be this much. Assume RC1 is 75. So MC1 can be found out. So this is equal to 3.14. So this is the total answer. Now, one thing I will tell you, that for this type of problem, this type of equation would be there for the static balancing. So xy plane, you just convert to everyone is xy plane. Okay. Like we have done this problem, like this, in this plane, all our things are given. This is MC1, this is MC2. We have assumed, okay. And this is the problem in actual with the angle 45 and thus. Okay, thank you.